Hello and welcome. Today we are diving headfirst into one of the most mind-bending questions in all of science and philosophy. It's an idea that's captured everyone's imagination, and for good reason. The question is this: are we, all of us, living inside a giant computer simulation?
Just pause and really let that sink in for a second. What if everything you've ever known, every memory you have, every emotion you've felt, every single sunrise you've ever seen is just code? Just a program running on some unimaginable hard drive somewhere. It's a wild thought, so let's actually dig into the arguments for and against it.
All right, so where did this whole idea really pick up steam in the modern era? Well, to get to the bottom of that, we have to start with the powerful philosophical argument that really launched it into the mainstream. This comes from a super famous 2003 paper by a philosopher named Nick Bostrom. He didn't say we are in a simulation. Instead, he presented this thing called a trilemma, arguing that one of these three statements right here has to be true. The logic goes like this: if we survive long enough to have godlike computing power, and if we still care about our history, we're probably going to run tons of ancestor simulations. And if that happens, well, it leads to a pretty shocking conclusion.
And this is the absolute kicker. In that future, the number of simulated people, simulated minds, would be astronomically larger than the number of original biological people. Think about it. One base reality, but potentially billions of simulated realities. All of a sudden, it just becomes a game of statistics. The odds that you happen to be one of the original few instead of one of the countless simulated minds, well, they're not in your favor.
Okay, that is a seriously compelling argument from a logic standpoint, right? It makes you think. But what happens when we move away from pure philosophy and start applying the cold hard laws of physics? Let's see what it would actually take to build one of these things. To figure this out, one astrophysicist, F. Vaza, started with a simple question: how much information would it take to perfectly simulate our entire visible universe? And that number you're looking at, that's the answer. Based on something called the holographic principle, that's the total amount of data, in bits, you'd need to describe everything down to the tiniest possible scale. It's a number so huge our brains can't even process it.
And this is where the idea just smacks into a wall of reality. This chart shows it all. The amount of energy you would need just to store all that information for the simulation is insanely larger than all the energy available in our entire universe. It's not just a little bit more, it's on a completely different scale. You basically can't build a computer big enough to simulate our universe inside our universe. So, fine, simulating the entire cosmos is out. But what if the simulators just cut corners? Only render the Earth in enough detail so we don't notice the glitches? Well, even then, the numbers are just absurd. At a low resolution, just good enough to match what we see in our science experiments, it would take over 14 million years of computer time just to move the simulation forward by 1 single second. It's completely impractical.
So the physics is a huge problem, an impossible energy bill, right? But the case against the simulation theory doesn't even stop there. What if the real barrier isn't physical at all, but logical? Let's look at an argument that our universe might be, by its very nature, impossible to compute.
Okay, this gets a little brainy, but it's super cool. A study from the University of British Columbia points to a massive roadblock based on the work of the famous logician Kurt Gödel. The argument is that our universe has what are called non-algorithmic truths. So what does that mean? Think of them as features of reality that are true, but they can't be proven or created just by following a set of rules. They exist outside of any rulebook that a computer program would have to follow.
And right here, this lays out the fundamental conflict perfectly. A simulation, by definition, is an algorithm. It's a giant, finite set of rules running on a machine. That's all it is. But if our universe contains truths that can't be produced by a set of rules, then you have a massive problem. You simply can't use a rule-based system to build a reality that contains things that don't follow rules.
This leads the study's lead author to a conclusion that is, well, pretty direct and to the point. The very way our reality seems to be built with these uncomputable elements baked in makes it impossible to copy with a computer. The issue isn't the hardware, it's the fundamental logic of the cosmos itself.
So, after all that, where does this leave us? We've looked at the philosophy, we've crunched the numbers with physics, and we've even wrestled with mathematical logic. So what's the verdict?
When you put it all side by side like this, the picture becomes pretty clear. We start with this incredibly clever and fascinating philosophical argument that says, statistically, we're probably in a simulation. But then, that idea runs headfirst into two gigantic walls. The physics wall says, sorry, you don't have nearly enough energy or computing time. And then the logic wall says, Even if you did, your reality has features that a computer program by definition can't even create.
So the big takeaway here is that while the simulation hypothesis is an absolutely fantastic thought experiment, the evidence we have from the real world suggests that our reality is just far too complex, way too energetic, and frankly, too logically weird to be running on a hard drive. And that leaves us with a final question that might be even more profound. If our universe can't be simulated because it's so incredibly complex, what other amazing secrets are just waiting to be discovered in the real thing?